Everyone, January the 3rd. All right, first one. Find the town judge. Have I done this before? Oh, that's a new one. Okay. In a town, there are n people labeled from 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then the town judge trusts nobody. Everybody except the town judge trusts the town judge. There is exactly one person that satisfies properties 1 and 2. You are given an array trust for trust I, representing that the person labeled AI trusts the person labeled BI. Return the label of the town judge. If the town judge exists, it can be identified. Otherwise, return -1. So, the town judge trusts nobody. What do you mean by trust nobody? So shouldn't be someone that's not in it, right? And everybody except for the town judge trusts the town judge. There is exactly one person that satisfies properties 1 and 2. There is exactly one person that satisfies, so only one town judge. So in here, I have 1 and 2. So 1 trusts 2, but 2 trusts nobody. So the town judge must be one that's not in it, right? That's not on the first value. And it must be on the second value with everybody else, because 1 to n, right? So 1, 2, they all trust 3. 1 trusts 3, 2 trusts 3, 3 trusts 1. So we have 1, 2, 3, so nobody is town judge. So what we're going to do is we're going to go through the whole thing, right? And count how many people trusts the person here, right? And also to count to see which value was not included, right? Which value is not included. Yeah, we can just go through. We can just go through 1 to n, and now I'll go through this, and every time we put, oh, can we do it easier? And we can remove, we can set a set, and every time we encounter, just remove the value, right? And then we also count, like for this, how many people are trusting. So eventually we'll have a bunch of values remaining. There are potential town judge, and then we go look into the counter. Basically, looking at the counter, we're trying to say, what? Trying to say how many people are trusting you. It has to be n minus 1, right? It has to be n minus 1. Okay, let's try this. I mean, this is an easy question, so I think this logic seems to be working. Okie dokie. Let's take a look. Alright, so I think I do need a counter. Alright, I'm going to import a counter. Alright, so what we're going to do is so I'm going to say counter shall equal to counter for this t in trust, and I will put t, right? So count this, and now we need to know who is not in it. What do? We can just go through everything, and then so I'm going to say people can be a set range 1 to n, right? And then just say for p in trust, if p in people, people dot remove P. So eventually, we can say for P in people, so these are potential Tom judges, right? And we say if counter P equals n minus 1, return P, right? Otherwise, return minus 1. Okay. Try it. So first test case we have 2, 1, 2, 2, x1, 3, 1, 3, 2, 3, 3, last one, 3, 10 minus 1. Okay. What I have here is n and trust. Find judge n and trust. Okay. Let's try this. Okay. All right. Done with it. So what should we say about this? It's O n, right? We run 712. Oh, 91% ranking. Okay. 997. So town judge must be the person that is not in the trust, not in the first element of each trust element. First value of each trust element. Town judge must have n minus 1 number of people trusting him. Thus, we use a counter to keep track of the number of people trusting a potential town judges, right? And use a set to identify which people are not in the first value of each trust element. If there is one person that fits both the counter and fits both requirement, she is the town judge. Yeah, that's about it. Directed graph. Well, let's see. Trusted person. Oh. 0 minus minus and trusted person 1 plus plus. Okay. So judge must be it's like in degree and out degree, right? Yeah, if I trust you, then I have out degree and you have in degree. So what we want to find is the people who have. Then why do we do this? Yeah, why do we do this? I don't think that's necessary though. Why do we do minus equal 1? Yeah, this is a good solution. Again, another one with in degree and out degree. All right, so this is inspired by. Think of the town judge as the person with n-1 in degrees. And since there are only one town judge, there should be only one node with n-1 in degrees. So we just can say in degrees equals 0 times n. Well, it's actually n plus 1. And then we say for this t in trust, right? In degrees t plus equal 1 if in degrees t is equal to n minus 1, then we return t, right? Otherwise return minus 1. Oh, that is not right. Oh, 3 does have in degrees. Ah, but it trusts somebody. Ah, that's why. I see. Also very important is to decrement, right? Decrement in degrees if a person trusts someone else. This is necessary. This prevents case where a person with n-1 in degrees also trusts other people. He, she shall not be the town judge. So we have two. I have to just go A and B, right? A and B. So we're gonna go in degrees A minus equal 1, in degrees B plus equal 1. We can now do this. Then for in degree in degrees, right? If in degrees equals to n-1, return. Oh, cannot do this. For I in range 1 to n plus 1. If in degrees I, then I'll return I. There we go. So that is the, yep, in degree. Oh, that's a good way to always thinking about this. In degree, out degree. Huh. Why is the difference so big? I don't know. It doesn't matter. It's the same. I have to set this on. That's on. Maybe we can get it faster. So yeah, okay. How about this? So n degrees potential, right? Potential is this, and then we say if in degrees. So I'm trying to avoid doing this. Okay, so how about we do a set, right? So if in degrees minus, we can never do minus, it has to be plus. So if in degrees b is equal to n minus 1, then pot dot add b. Alright? And then if a in pot dot remove a. So once we're done, we just need to check whatever's in the pot. Oh, then we probably just can say, because I remove, then we just say return minus 1 if not pot, or list pot 0. Not sure if this is. Wait, is this illegal? Oh, or else. How about this? Nope. Huh. 1 and empty. 1 person is empty. And then we go in degrees. And oh, we didn't go through this. Can we remedy it? But in the other case, I go through the entire thing and try to find. Okay, so I come out, I have no potential because we never got in it. Yeah. Is that the only case? Yeah, other case I will go through this. So maybe we can just say, wait, hold on. What if we have 2 people and then we have it empty? Is that illegal? Because you can have 2 potential. That is minus 1. So if I consider this as a special case, I'm going to say if not trust, I'll just return n is equal to 1. Return 1 if n is equal to 1, else minus 1. That's a special case. Let's see. How's this one go? Equally slow. I don't know why this one's so fast. Anyway, I don't like this, right? We don't like this. We want to go back to the previous one. Yep. I mean, this one we have a counter. We'll go through the entire trust. And then we have this. Then we go through the entire trust again. Right? And then we just remove, I don't know. Doesn't matter. It's my, but I do like the in degree and out degree idea. Okay. So we'll move on. Let's try this one. Department top 3 salaries. Oh, that's SQL. Nah. No. We don't want SQL. don't want SQL. What else do we have? There's the SQL. Shortest palindrome. How about this one? Shortest palindrome. String manipulation is always my weakness. Not good with strings. I guess it's just giving you a large string asking what is the shortest palindrome. Well, the shortest palindrome will be just a single letter. If you think about it. You're given a string S, you can convert S to a palindrome by adding characters in front of it. Return the shortest palindrome you can find by performing this transformation. So we add things in front of it. Okay, we can always make a palindrome, right? No matter what you have, I just make a copy of it. We can always make a palindrome. Good throw. And this will definitely have to go through the algorithm that I forgot what algorithm that is, but there's an algorithm that can, like about palindrome, can make it go faster. I never able to do it myself. So we have AACECAAA, right? So if that is the case, well, definitely we can add the same value to this, and then will become palindrome. But we only need to add one A to make a palindrome. Okay, A, B, C, D we have to add. Add 3. B, C, D. Okay. So what are we thinking about? So we're given any, right? We're going to add in front. I mean, can we just find not really the center, right? So if it's a even, 1, 2, 3, 4, 1, 2, 3, 4. If it's even, if we add 1, that become odd, right? So it's this value. So it's 1, 2, 3, 4. So it's 8 divided by 2 equals 4. 0, 1, 2, 3. Right? So it's going to be this one minus 1. If it's odd, that both are, so but like ABC, right? ABC. If it's odd, then we add a value that becomes even, right? It becomes even. So what do we check? I want this one, right? So this will be 3 divided by 2 minus 1, okay? So what we can say is just the n divided by 2 minus 1. That will be the value to start checking. So if initial lay is even, right? Then we say if we add 1 value, then we want to check if these are equal, these are equal, and these are equal. If they're all equal, then this one needs to be equal to this, then we're done. But what if they're not equal? So we're looking at here, and then it's not equal. Well, if it's not equal, that means we cannot do, right? We add 1 that cannot do, which means, but which one do we add? So we say we add 1, right? We don't know which one it is. And then if we add 1, if we add another one, the center will move to this one, right? So now we have, oh wait, center is still this one. Hold on. So we add this one, 1, 2, 3, 4, 1, 2, 3, 4. Add another one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, I need to move to this, but now we are even, right? And we check if these two are the same. If they're the same, then we can expand, right? either the same, then we can expand. But if they're not the same, that means at this level we cannot do. So we need to add one more. One more, then I stay in this position because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hold on. That's not right. We have 8, 9. So 8, 9, 10 should be 11. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. So it'll be 1, 1, 2, 3, 4, 5. So yeah, we stay the same value when it's become odd. Same value. So again, compare. So it's still not the same. Okay. So we add again. So we move here. Compare. Not the same. Add again. Come here. Compare. It's not the same. So coming here. That's the last one. Right. That's the last one. So the maximum will go through all these steps, and then each steps we need to check. But each steps we need to check multiple. So the thing is, if we have checked, like if it's one check, that's no good. Then we just move on, right? That's not nothing special. What does make it go slow is if we have something like A, B, something like this, which we add a B will work, but we can't because so now the first one check this, so they're the same, right? And then they're the same, and so same, but the last one is not the same. If the last one is not the same, hold on, we add one. Oh, that's even. Even we have to go with this one. My bad. It's. Wait. What if the original is a palindrome? Do we not add anything? If the original is a palindrome, I guess we just don't add anything. Yep, we don't add anything. Okay, so we're gonna check if the original is a palindrome, right? If it is not, then we're gonna try to add one, but we don't know which one it is. But it's a even number, so when it become odd, so it's this one. Say the value of 2 is 3, 3 minus 2, so 0, 1, 2. So that is the anchor point. And we compare same, the same, and the last one. So all the same. Yeah, that's basically what it is. And then we just add a B. All right, that's not a good test case. Like in this case, oh, there's no other way. Like they're all the same as a B, so we have to go all the A. Right? Should be AA, B, AA. This one. Yeah. So in this case, right, this is the anchor point. So these two are the same, and these are not the same, right? So we cannot do. So we have to add some value. So we don't know what value it is. And then because it's odd, so now it become even, right? So 1, 2, 3, 4. So we want to add. So this one we don't know, and now we're gonna add another value. So another value. 1, 2, 3, 4. 1, 2, 3, 4. So from odd to even, so we need to move here. And then we're going to compare. That's good. This is no good, right? So we're still no go. So we add another one. But we stay put. So we'll compare these two. Still no good. So we come here. I just lost the first one, so we know we have to do the eventually this. What I'm afraid is if I can match all of them, I match majority of them, and some does not match. If I match majority of them, and the last one does not match, then the last one, right? If I match some, right, then we stop somewhere. So like if I match, then we fail, right? It's no match. Then what do we do? Let's say 1, 2, 3, right? So first one be here, so we say we match. Right, we match, and then this one does not match. Let's say these two does not match. So what we can do is, well, since these does not match, if we set this one is the same, yeah, there's no go. The next one we have to move here, and then we do match. If anything that does not match, right? If something does not match, and then we have to go to the next round. The next round, the matching is all different. Let's try it. I mean, maybe this will all pass. Who knows? Yeah, exactly. Who knows? Maybe this one will pass. Okay, so what's my idea? My idea is if s equal to s, well, yeah, I'll return s. This is a edge case. If it's not, then midpoint. Mid will equal to minus divided by 2 minus 1. And is even equal to, is odd equal to minus 2. Yeah, so even. Okay. Then what is while true? While mid is larger than 0. Alright? So while mid is larger than 0, say if is even. Okay? So mid, we have a mid, and then it's even. So be odd. Right, then we're gonna go, so the current point, if it's even, right? And then 6 divided by 2 is 3 minus 1, so 0, 1, 2, right? So I'm going to do this, this. So I'm going to have a low and a high, right? Even low, high are equal to mid minus 1, mid plus 1, else low, high equals mid and mid plus 1. Oh, so high is always, okay, so low equals mid minus 1 if is even, else mid plus 1. Okay, that is low. High always become mid plus 1. So mid, Jesus, mid. Right, so we have low and high, right? Then they're going outwards. So while low is larger or equal to 0, and high is smaller than minus. Alright, so many times. Let's just go n equals minus. So all of these into n. Okay. Let me say if s low is equal, not equal to s high, so break, right? Else, if they're all the same, that means we have found. Else we can return something, right? Return something. Oh, hold on. Low minus equal 1, high plus equal 1, right? So when I compare if the same, and low minus 1, high plus 1, right? And I compare the same, low minus 1, high plus 1, and then low become minus 1. So high goes too far, right? And since I always, like, even if it's odd, right? Pointing here, right? This plus 1. So if something is not the same, hold up. When we fail, right? When we fail, like something is not right. So we try to add one value, right? And then when we fail, what do you mean by when we fail? When we fail is, this is anchor, so this is the same, so this one's fail, and then we have something more, right? We have something more. So it fails means we want to add a value, and it's not going to work. So it only works when they are the same. Is that right? Okay, so if that's the case, then when it's done, whatever the high points at, and actually we don't have to check high. High will definitely be within range, right? So if it's even, I'll pick this, we have one more left. If it's odd, right? 5, 6, we'll put this 2 is 2 minus 1 is 0, 1, right? We do this, 2, 3, 4, 5. Yes, so high will always point into the thing that needs to be added, right? So from high to the end. So what we need to do is return something plus s. It's going to be s for high to the end and minus 1, something like that. And when mid is 0, then we're going to return s from 1 plus s. Not sure. A, B, C, D. B, no, D, C, B, A, B, C, D. We'll see. We'll see how this one goes. Shortest padding than S. Yeah, what the heck? I forgot to change mid. Alright, so we break out, which is no good. Right, and then mid equals something if is even. Right. So if current is even, right, which means mid is here, we're preparing for odd, then the next step, do we change? So current is even, so 1, 2, 3, 4, 5, 6, right? And then we do 0, 1, 2, right? And then we add another one, so we check this. So it's now good, so we add another one. Yeah, so it has to go, so mid equals mid minus 1. If it's even, else mid. I can just say if is even, mid minus equal 1. If the currently is odd, right? If currently is odd, which means we're doing this, then we add another one, so we don't change. And is even equals not is even. Oh, that was bad. What the hell? That is not correct at all. What the hell? Let's go print low and high. So low we start, so 0, 1, 2. So 3 is the anchor point, right? So low is this, high is this. So it's equal 0, 1, 2, 3, 4, 5. 0 to 6. And come out, high is 7. 7 to the end. How do I reverse a substring? I don't like it. We don't have anything like that? Power of slicing. What is this minus 7 to 0 minus 1? Huh. I need to read about this, how this one is done. Something 0 and then minus 1. That is just, isn't that the interval of everything? Something to 0 will be just this. Then we go minus 1. Boop, boop, boop. Is that how it is? So, which means I should note, wait. So, will be high minus 1. Will be high, right? Because this side don't take 0. So, high minus 1. Yep. Okay, so the second one is still not right. Oh, of course it's not right, because I haven't changed this. So this one will be a 0, right? Nah, I think it's one with either timeout or Actually, I have no other idea. It's going to be either timeout or wrong. Oh my god, what is it going to be? I think a time's out. Yeah, this is like a naive solution. Of course, it's going to time out. Oh, I was wrong. I thought we timed out. It took so long. All right. AABBA. Oh, they have a smaller version. I didn't know that. AABBA. So AABBA, we should add ABB, right? ABB, right? But I did not add that. Okay, so how do I know? So it's 1, 2, 3, 4, 5, right? So we want to add 1. Then we compare these, no good, right? But 2, now we compare this, is good. Wait, how come this one I gave AABBA? I added ABBA. Wait. Hold on. 1, 2, 3, 4, 5, right? That's 5. So 5 divided by 2 minus 1 is 1, 0, 1. So that is, right? So when I compare these two, it's no good, right? So now we add more, and then so this is like 6. 1, 2, 3, 4, 5. Now we're gonna go 2. So 1, 2, 3, 4, 5, 6, 7. 7 is gonna be the same, right? The same. And then we compare these two. Is no good. Alright, so I'm moving here. Should we compare these two? Oh, so hold on. Hold on. Hold on. AABBA, right? If I want to add a 1 value, that's going to be 1, 2, 3, 4, 5, 6. So we have to compare this. It's no good, so we cannot add 1. So now if we want to add 2 values, 1, 2, 3, 4, 5, 6, 7, right? So I want to add 2 values, 7. So I have to compare this. And then no good. So now I want to add 3 values, 3, right? And then we have 1, 2, 3, 4, 5, 6, 7, 8. So compare this. It's good. So we should add BBA, right? Instead of so, which means, I mean, this can be remedied. That's AABBA, right? We shall return ABBA. Wait, no. ABBA. Current version is not right. So what we can do is just to do mid I is equal to 0, right? And if not, then we it's the last resort. Okay. Try it again. Yeah, now my timeout. Or it's wrong answer. I don't know. Timeout. Okay. That's fine. That's at least we know that this is a correct solution. It's just too slow. It's just too slow. Oh my goodness. Yep. I know exactly what this is. Oh, shoot. We got all A's. What? I don't see any other value. Are you telling me? Hold on. It's not. Wait. What did you do, man? Oh, it's already have it. Okay, try it again. Actually, how many we pass? 119. All right, we passed 119. So if we're just trying to pass this, we just need to fix this thing, and then we're good. Okay. Ooh. You're telling me it's not this? I guess it's not. It's not. There is something hidden inside. I didn't see. It must be like a. I don't know. I have no idea. I have no clue, man. Let's just return. Let me see. Let me just return this. We need to jump. Diff. Come on, come on, come on. Huh? What? What the heck is this? What the heck are you doing, man? I just want to see. Oh, there's a C and there's a D. What the heck? There we go. Oh, a C and D. I see you. Now I see you. Okay. Yeah. So it's no, because at every step we're gonna compare so much they're the same, and then we move. Yeah. So the question is, can we reuse the result of the comparison from the previous? So we have bunch, right? Or if I can get like A is something, then C, D, and A is something, right? What if we write it like this? Using group, right? So it will become tuples. How many? C, it will be 1, D will be 1, A will be another value. Hold on. So What are you trying to do? Well, I think there's something called group by from Iter tools. Import group by. I just go Iter tools. We have a group by. All I need to know is, so I want this, right? So list for kg in group by s, okay? So in group by s, list g, no, I want k and list g. So let's say compress equals this. And then let's just print compress. Oh, no, not list g, len g, my bad. It has no len. So we have to go list and then len. Huh? What? Oh, it's printing that. Ah, that's fine. Okay, so we have 2000. Yeah. So if we do everything like this, if we have a compress, right? Then what? Then what? So after compress, we have certain number of repeat, certain number of repeat, certain number, it will be like this, right? So I want different. No. For kg in group by s, right? Compress is equal to this. Then we can say compress dot append. Right, append what? Append k len list g. Well, if not compress, else this one plus compress minus 1. So this, oh, okay. So now I have their positions. You might want to put them into two different. So letters, indices. So if not letter dot append k, indices dot append. It's actually not the indices. Count. Don't say indices. It is indices. It's the last index, right? It's the last index. Is it index though? That's the number of count. The number of count minus 1. So we need the minus 1. Okay, so it's going to be this. Oh my God, hold on. The number of count and the number of count plus together minus 1. Yeah, I think it's pretty fine. Alright, so land this minus 1. I always do this, and this is not indices. I do this, else this is that append indices minus 1 plus this. And now we just print letters and indices. Okay, so that's their index. So we can do the same thing, right? We can do the same thing. I'm gonna pick. We do the same thing. We pick the middle, right? And then we're trying to compare. Now the comparison is different. Now we look into this, right? We'll land somewhere. So like this, we have first is 0 to 19999, and then that's a range 20,000. That's another range 1. Range. We're looking for range. Okay. And then of course from 20,000 to 4001. That's another range. So if my index is fallen into one of the range, the binary search. So if it's a binary search, we will end up somewhere, right? We end up somewhere, and then if it's a larger than, that must be in this range, right? That must be in this range. Now in this range, we need to check if it's in the middle. If it's in the middle, then we're good for this one. Then we check on the outer, right? If it's not in the middle, right? If it's not in the middle, that means on one side we have some value. On the other side we don't have enough, then we'll encounter a new one. But so all we need to see is if it's in the middle. Hold up. So let's say from bisect import bisect right. So we do this. No, I want this. Bisect right. I want this. Right. And I want this as well. Wait, do we want this? We can jump, right? We can jump. Because if we land and a column is no good, we keep going, it's going to be no good. So we have to completely jump out of it and then land in another range. So we don't have a ranges, right? We have a range. So if this one is no good, so we need to move to the, no, we want the middle. We want to find the middle of every range, because that's the only possibility, unless the middle is only 1. So now how do we do this? We want to find the middle. So the first one is, that is the middle, right? So the first one is the middle, and first one is in the middle. Then we're gonna say, let's go while true for now. No, while mid. I think this while is good, right? So we're gonna find we have the middle point. Now we're gonna go binary search. So index equals bisect right indices and what and mid. All right, and there are two scenarios, right? One is the index is, we find a match, right? If we find a match, I will look to the side, right? If we find a match, okay, let's say if it's we find a match. So if will mid be like here, smaller than the first one? Not likely. Yeah, it is likely if it's smaller, right? So if mid is smaller than first one, then that's when we break, right? So if index, let's just handle other thing, larger than zero. Right? Index is larger than zero. Then if indices index minus one is equal to mid, right? So we find match. So if mid matches one of the values, right? So I match, right? Then we need to see if how long the range is. If the range is 1, then we'll look to both sides to see if they're equal. Right? And if the range is 1, if the range, hold on. If we, that depends on where we end, right? If index we end at the first one, then that's it. End of the story, right? We have to go over the entire thing. So index, if index is 0, that means we end in the first round. If index is larger than 0, and if this is equal, if index is 0, or so index is larger than 0, or indices index minus 1 is equal to mid, right? So we land here. So match this. If it's larger, then it will belong to this. And we have one more chance, right? So if anyone lands within this range, either smaller than this, which is index equal to 0, or consider it equal, we will move to the latter one. So if it's minus this, right? index minus 1 is equal to mid, and index is equal to 1, and so we have this in these two situations, then we're done. Right, we're done. So we can just return because anyone in there, we have to return the remaining, put that to the front, right? So the remaining to the front. So anywhere else, if we have these two matching, right? Matching. Match. Because this one there's nothing matching. Right? So I think this one we can return. Return what? Return something plus s, right? What is this something? It shall be the entire on the first, right? And then starting from the second starting position. So it should be indices 1. Oh, what if we only have... Okay. We can... Alright. If s is equal to... So edge case handled. So now indices will definitely be 2. Because if indices has only one value, this one shall handle it. So I'll just return this 1, right? No, it's a 0. Right, and 0, we don't go with the 0, so we should say s all the way to here, right? But we don't go here, then we go minus 1. So that's that. Okay. Else, which is index is not equal to 0, or so the mid did not end in the first range, right? So mid is not in the first range, so mid is in some other range. Then we're gonna see mid is in some other range. Mid is in some other range. What do? We grab the entire range. Well, we try to find the middle of the range, right? Oh, that doesn't matter, right? We just need to know which range it is, right? We want to know which range it is. So we got an index. Index will be from this to this. Right? If it's larger, then that's minus 1. Otherwise, it's in this and this, right? Or we go in between, so we point into this, which is fine. So otherwise, we say if indices index minus 1 is equal to mid, then index minus equal 1, right? So index now pointing to the range that we're looking for, right? The range we're looking for. Now what? Now what? Well, now what we want to do is doesn't matter because this is the repeating, right? So it doesn't matter how long it is. We will take this whole thing as the midpoint. Now we're just going to go look to either side to see if they're equal, right? So because it's a stretch, right? This is just a stretch. So low, high shall equal to index minus 1, index plus 1, right? And while low is larger than 0 and high is smaller than len indices, right? We say if letters low is equal to letters high, then low minus equal 1, high plus equal 1. Else break, which, yeah, I feel like it's better to do it this way. If they're not the same, then break, right? If they are all the same, so we have this and they're all the same, right? If they're all the same, then else and return stuff. I don't know what it is, but if they're not the same, I'll handle this later. If they're not the same, so they're not the same, then what do? Well, then index. Hold on. I think this is our start. This shall be the starting point. We don't really care about the mid, right? We care about the index. I probably don't need this as well. We care about the index. And yeah, I don't know about this. I just go true for now. Now where do the index go? So basically, let's say the index is on this, so it's this range, right? So it's not gonna go. So index is minus equal 1. Yeah, so index just minus equal 1 to go to the previous one. Now we check again. No good. Index minus equal 1. Alright, just index minus equal 1 until index is 0. Yeah, then we return something. Okay. So what do we return this? So this is just low is 0, high is, no, we're done, right? So we have so when it comes out, oh shoot, not only do they have if letters not equal or the count is not equal. So there are two things, right? So if the letters are not equal and the count is not equal, then that's no good. So how do we do count? Well, count is going to be we just do this minus this. Or What if we add something here? Like this. Okay. And then this is index, right? So if index is equal to 1, if index is equal to 1, which means the length between these, right? If index is equal to 1 or index is 2, what used to say if index is equal 1 or index 1, right, is equal to mid, then we do indices 1. Else, if index minus 1 equals mid, equal to index, and low or high, so low shall be larger equal to 1, high is smaller equal to, that's fine. If low or this is not equal to this, will be indices low minus indices low minus 1, not equal to indices high minus indices high minus 1. So the count, the number of letters, if they're not equal, then we have to break at index minus 1. Otherwise, they're all equal, they're all equal, they're all equal, and then come out. So either low is larger or equal to 1. So in this case, we're going to say we can exhaust high, but not exhaust low. Like this is equal, right? And then boom. We don't have high, but we have low. In that case, what we're saying is this is good, but then we need to add to the end. So this is no good, right? So aleph low is equal to 1. So low has to be equal to 1, right? If low is not equal to 1, that means we're not done yet. So aleph low is equal to 1, okay? So low is now 1. So we're exhausted, right? No, if low is equal to 0, so we have to do minus equal to 1. If low is 0, that means we exhausted low, right? If we exhausted low, we can exhaust high, it doesn't really matter, right? If we exhaust or not exhaust. So in that case, high is going to be plus 1, right? So basically this is the same, and low, high, go to the higher one, right? And because if it is a palindrome, then we simply can we have already returned, so it's not a palindrome. So high must be something. We must have something there, right? So high, we must have something there. What do we do? What we're gonna do is, for whatever the high is there, we put in the front, okay? So how do we do this? So high all the way to, so let's say prefix is this, right? So for I in range from high to len indices, right? So each one of them I'm going to say pre plus equal to letters high, right? Letters high times what? Times, we need to count indices high minus indices high minus 1 plus 1. Right, we just add this, and then we reverse it. So pre, I'm going to add this, now I'm going to return pre reverse plus s. Oh, there's no elif. It only has else. Okay, that's fine. Let's say else if low is equal to 0. Now we do this. Name mid is not defined. Of course, mid is not defined. Index. Oh, shit. I think this is what we need to do here. We want to know the index, right? So it's equal to this. The in bisect right. So we grab the index, and that index might be too big, right? The index might be too big. Now mid might be otherwise. If it's too big, right? It's the same, so we put this, and then we say the same, so we go down. So that we basically find what letters is kind of in the middle, right? What letter is kind of in the middle, and that's what our starting point. From here, and we go from both sides. Honestly, we can actually go. Well, actually, we don't really need this. I just directly say if this is equal to 1. Nope. Answer. Hold up. Let's try the others. It's not right. One at a time. Alright, so A have 2. That's. Oh. What is this? Oh, wait, that's. 0, 1, 2, 3. Right? And this minus. You know what? Maybe using count is easier to handle. I am using count. I just realized. I have 2, 3, 4, 5, 8, right? And I want to find a middle. Now these are not indices then. I'll go -1. Oh. So the last index Okay, so 0, 1, 2, 3, 4, 5, 6, 7. Okay, now we're talking about indices. And that's fine. Index. So what's the index? Index is 3. So 0, 1, 2, 3. So index pointing to this one. 0, 1, 2, 3. So it's E. That's where the index is pointing at. Okay? So low will be here. High will be here. So if they're the same, right? If they are the same, so this minus this is 1. This minus this is 1. Okay, so I'll keep going. Low is here, high is here. Low is 1 and high is 1. Low is 1, high is, and then we compare these two. They are the same size. They're the same letter but different size, but one is 3, the other is 2. Then we break. So what it's saying is if the same letter but different length, right? Same letter but different length, depending on where is the low. Same letter, same length, we keep going. So else coming out, and then we check again. Coming out, let's say, right? So coming out, let's say if low is 0, which means, yeah, so that's the good part. Else, so low is not 0, right? And aleph high is still smaller than len indices. So that means high is still pointing to something, right? If a high is going above, then we don't. So high is still pointing to something. Now we say if. So they come out. So if letters low, right? No. Hold on. And then break out. So we don't go else. Else is this one exhausted. So we break out. Someone here is wrong. So we just say if letters low is equal to letters high and low is equal to 1, right? So that means we low and high, right? So then in this case, all we need to do, what if, then we have, if low length is smaller than high, we just add a bunch and then keep going, right? If low is larger, this is smaller, then everything else and everything in the center is matched. So we match on this one, right? This is the one. And then in this case, they are all matching. Shit.
can use, right? This one and this one cannot use because this is larger, this is smaller, and everything in the middle is all matching. So we need to match these two, but this is too big. I can only match this to this, right? So no, I have to match the entire thing. So if this equals this, and this is equal to 1, and indices, low minus indices, low minus 1 is smaller than indices, high minus indices, high minus 1, right? If that is the case, because if the front is too big, then we cannot do anything. I don't see how we can do this, right? Yeah, we can't. There's like a bunch of A, a B, and like 3A, a B, and a 2A, right? Then, like, let me see, so A, B, A. The result has to be for the other one there. Okay, so if that's the case, but if we have A, B, A, that's a different story. If we have A, B, A, then what we're saying is, if we have this, then what we're saying is, we can add one more. So we can just return, right? Return. So whatever is the difference between this. So, okay, also prefix will equal to letters low times the difference between the two. So it will be, this is the count, that's too big, minus this count, right? And then for I in range I plus 1, and then we add the remaining to len indices. Then it will be the same thing. Pre plus equal to this. And now I'm going to turn pre plus this. You see, these two can be combined, so I'm going to break out and check, right? So I'm going to break out and check if low is 0. Break out. If low is 0, I don't need else. Okay. And in this case, I'm pretty sure, I think index can just be len indices minus 2. Right? And then this is not going to be while true. It is while true. If it's 1, index is 1. Then we do this. Right.
Otherwise, if we try this, if low is 0, that means we all match. Then we just add the remaining. If low is 1, and we have all these matching. Otherwise, do this. Okay, they all pass. All right, let's try this. Got a wrong answer. That's fine. That's fine. I think this is promising, but it's true that there are still a few. That's weird. A bunch of C's. Hold up. I'm just gonna go letters, indices. Okay. And when we start, land this -2, so we started this, right? And check no good. Start here. Check no good. Start here. B. Check. Oh, that's good. How about the count? Well, the count is 1, and here the count is 1, so that's good, right? So it would be in this case, right? Low is equal to 0, and then from high will be here, right? To land indices, So pre plus equal to letters high. Oh, +1. Nah, that's just gonna be this. It's just gonna be this. Yeah, still not right. Hold on, what is high? 0, 0, 1, 2, 3, 4. Yeah. So C 0, 1, 2, 3, 4. Letters high. Oh shit. I. It's not high. Dang it. That's I. My goodness. Alright. That's a weird bug, huh? Alright. Try this one. Index out of range. Why would index out of range? So when we come out, well, low is not 0, I check. So low is supposed to be, so high, right? And low equals 1, and high is smaller than len indices, and Oh yeah. What the hell? Oh, I used high already. I see. I see. Okay. Try this. All right. Try it again. Oh, still doesn't seem to be right. Oh, we got it. Oh my god. This is pretty hard. Expect this. All right. 54%. 54%. All right. So yeah, I'm gonna end it right now because it's kind of late. Yeah, it's always hard to do a hard question. All right. I'll go read the solution and see you guys tomorrow. Adios.